Hello, I'm Nazar Kopich and I will present you my study on the Ising model with external inhomogeneous field. So, at first, what is Ising model and why its study can be useful? Ising model is a static physics theoretical model that describes materials magnetization behavior. The study can be useful for researching materials exhibiting ferromagnetic properties. For studying the model behavior was developed a computer simulation based on Metropol's algorithm, adjusted for the case of external inhomogeneous field. The steps of it are shown on the slide. The simulation allows experiment with such parameters: temperature, lattice size, and field distribution law. At first, were analyzed trivial cases without external field. The results correspond to early known data. Then were considered cases with homogeneous external field. As it was expected, most of spins were oriented to direction corresponding to field's direction. The cases when the distribution isn't homogeneous are more interesting, as the simplest type of it was considered cases with linear distribution. Can be noticed that models became divided on two zones. The first one, where field's density is low and structure is similar to the case with no field, and also a zone with high field density, where most of spins are directed in one particular direction. Even more interesting are cases with quadratic distribution. It can be easily noticed that distribution of magnetization, which occurs under action of an external field, often repeats the mathematical law of field distribution. For the curiosity interest, we also consider some cases that can hardly be encountered in real life, but they gain interesting results. As an example, a sinusoidal distribution produced interference-like structure. So, let's go to conclusions. Based on the adjusted Metropol's algorithm, was created a program that allows real-time simulation of an Ising model with an arbitrary distribution of the external field. Using the program, a number of numerical experiments with different temperature and distributions of the field were conducted. It was noticed that the distribution of magnetization, which occurs under the action of an external field, often repeats the mathematical law of field distribution. That's all. Thanks for your attention.